Hello, in this video we present the main aspects of our medical image processing project. The goal of this system is process MRI image of MFTI format and generate statistical and visual information that can support the analysis of tumors or lesions. We have developed an interactive application using KeyChai for the graphical interface and OpenCV for image manipulation and ETKI for reading medical image. Let's first take a look of the architecture of the systems. You can see in this diagram our system is composed of three main components. First of all, the graphical user interface is made with main windows built with KT, and the image processing logic where the core operations are performed using OpenCV and ATK. The external libraries and utilities which help the use with reading, visualization, and saving image. The main window component provides iteration with the user, allowing them to select the folder and image, configure filters, and process either a single slice of entire batch. Now we are the with the processing workflow. Now let's take a look of this diagram. First of all, now let's analyze the processing workflow of the application. First, the user loads a folder containing any AI image. We read this image using ETK and convert them to OpenCV format with ATK to maths, allowing use to perform efficient image processing. Once the conversion is done, the user can apply different filters throughout the interface. This includes histogram equalization, game correlation, and various morphological operations. The processing is performed on selected slides or batch of slides. Now we're going to explain the tumor segmentation aesthetics. A key component of the workflow is the tumor max. For each slide, we extract corresponding segmentation max and apply it to just large duration of the interested tumor area. Then we compute several statistics for these regions. We have minimum, maximum, median, and the tumor area in pixels. Then we have the memory monitoring. As you can see in the image, we have an example of that, where we have a graphic with the memory consumption memory and number of slices. Then we have some CSV data frames. Let me take a moment. For example, we have here an example of that. This data is generated automatically by the program, each by slice. And then we have the outliers detection. As you can see in the image, we have the outliers detection using the collected pixel intensities. We compute the IQR and identify stream values, outliers, which are exported to outlier CSV and visualized in a dedicated graph. This helps highlight anomalous intensities that may require further clinical analysis. And then finally we have the summary. We generated some graphics for the analysis of the image. For example, we have some box plots and histograms to analyze the data, and the result for the previous explanation. Now we are going to explain with the program. Thank you so much.
Good afternoon, engineer. In this part, I am going to show how our application works. First, we must load the dataset, or further we where we have our image point and II. Okay, once we load, we can see that it takes a reference the flyer file. We are going to enter two slides that we want to see for the tumor detection. We see that already in the 17 we already visualize part of the tumor. Now we are going to enter the 100. We observe that we already have all the tumor detected, and it is highlighted in red color. Are going to enter filters that we use with OpenCV. If we apply this filter, we see that the tumor is highlighted. And with dense filters, we can see the intensity of the tumor. Finally, we are going to process the batches, which will use image with that range of generate an automatic video to see how the tumor was formed. We have the graphs with Python that will help use for a medical image. Thank you.